So thank you, Professor Basso, for your kind presentation and also for inviting me to talk about this topic, which is of great relevance to both occupational physicians and pathologists. This is my presentation outline. Today, I talk about the property of formaldehyde, source of exposure, formaldehyde metabolism and health effects. Something about the framework, the regulatory framework, and environmental monitoring, risk assessment, and occupational exposure to formaldehyde. Above all, risk management and prevention measures. And finally, I will briefly discuss with you some current evidence regarding possible alternatives to formaldehyde. I think that is a very important concern today. In the slide, I report also that I have no conflict of interest to disclose. So, some information, some basic information about formaldehyde. It is a colorless gas at room temperature with a strong, pungent, and irritative odor, which is usually perceived even at very low concentrations in the ambient, in the environment. I report in the slide also the odor detection threshold that is very low. Formaldehyde presents a nice solubility in water. The commercial 37% solution is known as formalin and used, as you know, has a preservative and fixatives for tissue. The chemical characteristics explain both its effectiveness as a fixative and its potential to generate occupational exposure through vapor release during handling procedures. In this slide, I reported the main sources of occupational exposure. Formaldehyde is not only a contaminant of your environmental work, but also it is present in many other environmental occupational settings. For example, production of formaldehyde-based synthetic resins, production of disinfectants, cosmetics, manufacture of wood-based panels, also paper industry, textile industry, plastic manufacturing, in particular urea formaldehyde-based, foundries, agriculture, is also a contaminant in the office, in the environmental indoor office, and so on. But, however, the application in the healthcare settings are the more relevant, and in particular for us. And on the side, on the right side of the slide, I report, I listed the main applications in our healthcare settings. Scusate, excuse me. An important concern is that formaldehyde is not only an occupational compound substance present in environmental and occupational environment, but also is a formaldehyde, a ubiquitous pollutant present both in indoor and outdoor environments. Indoor pollutant usually represent the main sources for general population and can release from, for example, furniture and wood products, painted insulating materials, textile products such as carpet, fabrics, but also derive from combustion sources, wood stoves, cooking activities, and cigarette smoke, of course, and also released from household hygiene and cosmetic products. Outdoor concentration usually are lower than indoor concentrations, and it is released from motor vehicle exhaust emission, combustion decomposition of biomass, derive from photochemical oxidation reactions and emission from industrial facility, of course. At the bottom of the slide, I report the concentration ranges for indoor and outdoor environment, respectively. Understanding the metabolism of formaldehyde is important also to understand the health effects. Formaldehyde in aqueous solution rapidly converted in methylene glycol, the two forms existing in dynamic equilibrium. And after the inhalation, formaldehyde is rapidly absorbed in the upper respiratory tract and is efficiently detoxified through glutathione dependent metabolic pathway and react with glutathione to form S-hydroxymethylglutathione, which is subsequently metabolized in formate and finally in carbon dioxide. One very important concern is that due to its rapid metabolism and high local reactivity, inhaled formaldehyde primarily affect the tissue at the site of the first contact. And the health effect depend also for this. The severity of the effect depend also on airborne concentration level, duration of exposure, the product from the dose that is very important for us, for occupational physicians, and depend also on individual susceptibility. The irritative effect are primarily on the eyes, skin, respiratory tract, but formaldehyde is also an important skin sensitizer that can cause allergic contact dermatitis. The role of formaldehyde as a respiratory sensitizer remain more controversial. In fact, only isolated cases of occupational asthma have been reported despite the very large number of exposed workers worldwide. And formaldehyde is also classified as a human carcinogen because it can increase the risk of, in particular, nasopharyngeal cancer. Experimental studies confirmed in several animal species the mutagenic and carcinogenic effect. The evidence in human is more controversial, and also the last systematic reviews pose a controversial insight about the carcinogenic risk in humans, but in 2004, International Agency for Research on Cancer classified the formaldehyde as a carcinogen of group 1, carcinogenic to humans, with sufficient evidence for nasopharyngeal cancer, more limited evidence for cancer of nasal cavity, and some evidence, but not sufficient for leukemia. In the table are reported also other classification from other international agencies. Particularly important for at European level is the SCOEL classification, SCOEL Scientific Committee on Occupational Exposure Limits, that was the technical advisory committee responsible for the development of occupational exposure limit values, supporting the decision the European Union. The SCOEL some years ago was replaced by the ECA, the Evaluation Chemical European Agency. But is interesting observe the methodology of SCOEL for the assessment of carcinogenic agents since 2008 that divided or classified the carcinogenic substance in 4 diverse categories, in particular formaldehyde entry in the group C, genotoxic carcinogens for which a practical threshold is supported. So this is because a weak genotoxic agent, because formaldehyde is a substance with weak genotoxic effect and whose effects are driven mainly by more relevant secondary mechanisms, such as local cytotoxicity for formaldehyde. For these substances that enter in the group C, a practical threshold can be established and below which no significant carcinogenic risk is expected. This is very important. This classification is important to define the occupational exposure limit based on the threshold that is possible to set. In the slide is reported also the occupational exposure limits defined by other international agencies. Also in Italy, we have an occupational exposure limit that is equal to this set by SCOEL and the FG. The FG is a German agency that define occupational exposure limit. The occupational exposure limit for formaldehyde is 0.37 milligram per cubic meter, has a TVA, time-weighted average. We have also a short-term exposure limit for 50 minutes set at 0.74 milligram per cubic meter. In occupational medicine and in the risk management, it's also important to use an action level. The action level is a level of exposure, usually a fraction of occupational exposure limit, that when exceeded triggers for the implementation of corrective measures and or preventive action for the exposed individual. And so is a fundamental tools to do risk management. And another important concern is that for pollutant, for ubiquitous pollutant, in particular carcinogenic pollutant, refer to the guideline value established for general population. Because this value represent for occupational medicine and for prevention operator workers a target to go on. So the World Health Organization for formaldehyde recommend an indoor air quality guideline for general population of 0.1 milligram per cubic meter. It's also important understand what is the scientific basis for the derivation of the occupational exposure limit for formaldehyde. I synthesized on the right side the main concern that I proposed. All exposure limits are based on irritative or cytotoxic effects for formaldehyde, which occur at concentrations lower, substantially lower by more than 1 order of magnitude than those associated with carcinogenic effects. And since irritative and cytotoxic effects are a necessary step for the development of nasal cancer, exposure limit established on the basis of these effects are considered protective against local carcinogenic effects. So the occupational exposure limits can consider health-based. With regard to systemic and distant site carcinogenic effects, the rapid metabolism and the fact that it is also an endogenous, metabolite makes such effect at low exposure level biologically implausible. Under the European regulation, formaldehyde meets the criteria for classification as a carcinogen substance. Category 1B may cause cancer. In the table are also reported all hazard statements that you can find, for example, on technical sheet, okay? And this hazard classification has resulted in a series of legal requirements concerning exposure monitoring, risk assessment and management, and also health surveillance of healthcare workers or workers in other settings. Our legislation establishes that for carcinogenic and mutagenic agents, exposure assessment is always be carried out, even at low exposure level, through environmental monitoring campaign, according to technical standard for occupational exposure assessment, that report general requirement for the performance or for the measurement, but also report strategies for testing occupational exposure for the compliance with occupational exposure limit. And so the results of the environmental environmental monitoring campaign, the result of this must be compared with occupational exposure limit for risk assessment. But exposure monitoring is necessary also for pre and post intervention evaluations to assess the effectiveness of measures implemented to minimize exposure. And these are particularly important. In our institute, we have a lab directed by Professor Carrieri that performed the environmental monitoring and also for other substances, for example, biological monitoring. Our legislation establishes a hierarchy of prevention measures for carcinogenic substances. First of all, the first priority measure are primary prevention measures, and in particular eliminate the carcinogenic substance or process, in this case formaldehyde, whenever technically feasible. If is not feasible, replace the carcinogenic with a less hazardous substance, mixture or compound. But now, to date, replacing formaldehyde has not yet proven to be a realistic option, even if at the end of my presentation, we discuss about this concern. So if elimination or substitution is not possible, engineering controls and administrative controls were carried out. In particular, is necessary to implement local exhaust ventilation, general ventilation, proper maintenance of systems, availability of ventilated storage cabinet for sealed containers holding anatomic specimen. And it's important to also minimize the number of exposed workers, reduce, if it's possible, the duration and the intensity of exposure by implement the primary prevention measures, And also is important the compliance of the procedures, no? And also the training programs for workers. Personal protective equipment in occupational medicine and in our legislation is not considered the first safety measure. It should be adopted in order to further reduce risk and should be used together with collective preventive and protective measures. In these slides, our sensitivities are reported some engineer control, workstation, ventilated cabinet, and so on, has a primary prevention measure in healthcare setting to control the environmental exposure to formaldehyde. The legislation establishes also that it is not possible eliminate or substitute the carcinogenic substance. Is important whenever possible adopt the closed system. This is possible, for example, in operating theater or in autopsy theaters to minimize risk and reduce also the number of exposed workers. Example include for small to medium-sized biopsy specimens, pre-filled containers with a barrier solution, for example, isoparaffin-based barrier layer, or dual compartment containers that is present, for example, that are present in our operating rooms. For larger specimens, it's possible to use a vacuum cell transport system with or without subsequent introduction of a preservative, and also these systems are present in our operating room. This is an interesting manuscript that is a report, is a systematic review on occupational assessment of formaldehyde in several occupational scenarios, involving also healthcare and research setting. The table is not very legible, but on the right, I reported the environmental ranges measured in healthcare settings. In particular, personal environmental exposure present a wide range of values from 0.01 to 482 milligram per cubic meter. I remember you that the occupational exposure limit has a time-weighted average values R is 0.37 milligram per cubic meter. The wide ranges demonstrate the high variability in the occupational settings, also in hospital, and the highest value to generally occur during gross examination and procedure involving large volume of formalin. Our university hospital. In this slide, I report measurement carried out by our laboratory, our industrial hygiene lab. And in the slide were reported 2 5 years period, reported environmental monitoring campaign of personal exposure. You can see, and this measurement are carried out by also a working setting, so operating rooms, endoscopy clinics, pathology lab, also cardiovascular pathology. And as you can see, the time-weighted average value, the red bar, present values well under the occupational exposure limit, but occasionally some measurements are highest, and this is for the no compliance with procedures, with the correct procedures. And so the measurement show clearly the importance of the compliance with correct procedures, and also on training of operators, of workers. Operating rooms present lower values in respect to pathology lab, of course. The two different periods show in the maximum value the difference related to the introduction of the closed system in the operating room. And the time-weighted average value are very, very low, and under the value of general population, and the situation is well controlled. On the left, in the corner on the left side of the slide, I report some values measured in local, in location where workers didn't work stably during all day, but it's important to observe that there are many values or some values above the occupational exposure limits. Okay. Also, if workers work stably continuously in this ambient, and this is a concern for the prevention figures to find or to implement the control measure of this environment. So it's possible to list some recommendation. Some exposure scenarios are influenced by work procedures that are not always performed correctly. highlighting the importance of the written procedures and standard operating instructions. Regular information, education, and training programs are essential for occupational, for workers, and to have a compliance with the correct work practices. Greater attention should be paid to the design and organization of support area outside the lab, where personnel do not work continuously, but where higher contamination levels are often detected. Specimen storage rooms, formaldehyde storage areas, archives, and so on. Only a limited number of specimen awaiting analysis should be kept in the lab. Fume hoods should not be used as storage areas for specimens, as this may impair their extraction efficiency and compromise the effectiveness of the control measures, and also ventilation and control system should undergo regular maintenance. And at the end, you can see that no single control measure alone is sufficient. For occupational physician is also important the health surveillance of workers. The scientific our scientific organization produced last year a new document about the health surveillance protocols in the healthcare settings and also for formaldehyde. The interest for me is the approach reported in this document that established that when personal exposure it is within the limit established for the general population, the health surveillance is not required because the dose is similar to this general population. In our hospital, for example, this is for the operating room personnel, okay? When personal exposure is between the limit for general population and the action level, that is a fraction of occupational exposure limit, the health surveillance is required, and the health surveillance follow-up it depends from risk assessment, is related to intensity and duration of exposure. At the end of my presentation, only a few words about alternative to formaldehydes. This is a new concern. I talk about few months ago, I participate at a meeting in Rome at the headquarters of ENIL. ENIL is obviously interest for your mission to verify these opportunities. I would say that this concern is not a occupational medicine concern, because the alternatives of formaldehyde is less dangerous, is more present a safety profile, and is a concern for the pathologists, okay? Because the pathologists decided if in the routine practice this alternative fixative performed like formaldehyde, okay? And only 2 manuscripts from a research group from University of Torino, that the manuscript present the glyoxal acid-free as a substitute of a formaldehyde. It is a commercial a commercial dialdehyde with reduced toxicity. In particular, is not in particular glyoxal acid-free is not cancerogenic substance, and the aim of the study was to assess the non-inferiority of GF compared with phosphate buffered formalin, to evaluate the morphological and diagnostic quality, to compare nuclear and cytoplasm preservation, to assess the reliability of immunohistochemical analysis, and another manuscript of the same research group find to evaluate alternative fixation protocols to compare 4 different alternatives to formaldehyde: neutral buffered formalin, acid-deprived formalin called ADF, and glyoxal acid-free, to assess DNA integrity and the next generation sequences, and to improve comprehensive genomic profiling. And for synthesize, in this slide, I report the main conclusion or the main consideration from this manuscript, okay? So GF or other acid-free fixatives reduce the risk associated with occupational exposure to formaldehyde, is non-inferior to phosphate buffered formalin for routine histopathological diagnostic. Preservation of nucleic acid is improved with acid-free fixative, resulting in less DNF fragmentation, and also fewer artifacts. Performance in genomic and next generation sequences analysis is superior to that conventional formalin fixation. Reducing fixation-related artifact enhance the reliability comprehensive genomic profile, and this, for the authors, is important for the accurate identification of biomarker for target therapies. And to finish, also another manuscript from Montisci published in the 2025, only to say that because the manuscript report also the relevance for the forensic practice. In this manuscript, GAF may improve the quality and the reliability of both histopathological and molecular forensics investigation while ensuring long-term preservation of evidentiary materials. So I think, and all authors of this manuscript conclude also that larger multicenter studies and the international standardization of the protocols are still needed before alternative can be widely implemented in routine pathology and forensic practice. And I think also that is important to do a cost-benefit balance and evaluate the advanced pathology workstation with introduction with several technologies, has remote and continuous monitoring for formaldehyde, risk mitigation strategies, digital transformation, and so on, versus alternative to formaldehyde. And I finished then. Thank you very much for your attention.